In this video, we will answer some questions about some exponential functions. At no point will we use a scientific calculator. And if I do use a scientific calculator, I am going to pretend that it is just a four-function calculator. Instead of a calculator, I will often use a chart like this for my exponential values. Look at problem number 1. If I want to evaluate this without using a calculator, I need to know that this rational exponent, this fraction, is in the form power over root. Alright, it's always power over root. So that means the 3 is the root. So I'm looking at the cube root of 64. And then 2 is the power, so that will be raised to the second power. But the cube root of 64, I know that that is 4. But if you don't know that, the cube root of 64 is 4. That's how you do it on the chart. So that means inside of the parentheses here, I just have 4. And then that's going to be 4 squared, which of course is 16. Alright, let's take a look at number 2. Now, this one has this negative on it. So remember that a negative exponent does not make the answer negative. Oh no. Instead, it's going to drop you down to the denominator. So this is going to be the same thing as 1 over 8 to the 2/3 power. Alright, the negative dropped it down to the denominator. Now, still power over root. So once again, alright, we'll throw in the 1 over aspect, but 3 is the root, so we're talking about the cube root of 8. And then 2 is the power, so I'm going to square all that. Okay, so I've got 1 over. The cube root of 8 is 2. And again, if you need the chart, use it. The cube root of 8 is 2. And then 2 squared, of course, is 4. So the final answer will be 1 over 4. All right, how about number 3? So let's be careful. We have a negative here that we have to deal with. This is negative, so I'm going to have 1 over, and now I've got my negative 36 to the 3 over 2 power. That's weird. So actually this is going to end up being no solution because power over root. Alright, so 2 is the root. So I've got the square root of negative 36. And then that's going to be raised to the 3rd power. But the square root of a negative number is imaginary. So we're just going to stop there and just say no solution. Alright, we're not going to deal with imaginary for this unit, so we'll just stop. Okay, so that's a little review of rational exponents. Alright, we need that because they come up. Now look at number 4. I better zoom out a little so we can read all this stuff. Okay, it says create an exponential function that is vertically stretched by a factor of 2 and has a range of negative infinity to 4. Now keep in mind that the general model for an exponential function is like we have a times b to the x power. And then if we start shifting things around, we can have x minus h, that's a left or right shift, and then we can have plus k, and this would be an up or down shift. So this is the general model. It's a horrible b there. So vertically stretched by a factor of 2. We're talking about the a value in that case. So if it's going to be vertically stretched by a factor of 2, then this needs to be a 2. The a value is going to be a 2. Okay, so we have that. Now, the range is going to be negative infinity to 4. So let's do a sketch. Okay, when there is no h and there is no k, your typical wait, what happened to my 2? Your typical exponential function goes like this. Alright, so normally there's an asymptote here at 0, the x-axis. So the range would normally be 0 to infinity. Okay, because it goes from 0 and then it goes up from there. Now, so for starters, I see that this has a negative infinity. So that means somehow it has to come up from below. It has to be negative infinity. Okay, so that tells me that I am dealing with a reflection over the x-axis. Okay, if I had something like this, then this green would have a range of negative infinity to 0, the way it is right now. So the fact that there's a negative infinity in front of this range tells me that it has to be reflected over the x-axis. So to do that, I need a negative in front. Now it's reflected over the x-axis. But what else? Like I said, right now it's going from negative infinity to 0. But it's supposed to go from negative infinity to 4. Alright, so we need to make an additional change. Alright, so 4. So 1, 2, 3, 4. The asymptote must be up here. So I need to take this and move it up 4 like this. Alright, so it has to be shifted up 4. And if I'm going to get a shift of up 4, then that's the k value. So this k value needs to be plus 4. Okay, so it really doesn't matter what the b value is, and it doesn't matter, you don't need an h value. So I'm just going to erase the minus h part. So basically, your function is going to take this form. So you can let your b value be anything that you want. So I'm going to say I'll let b be 3, just for fun. Okay, so let me just go ahead and do that. So I'll just put 3 to the x power. Alright, so this is one answer. So basically, your answer should look something like this, but you could really have anything you want here, but it can't be a negative number, and you know, it can't be 0, and it can't be 1. But you could put anything else. Alright, let's move on to number 5. What is the range of this problem? Okay, maybe I should do a little sketch of that. So the range. So you see the plus 5. So as I do my little sketch, 1, 2, 3, 4, 5. So I know the asymptote is going to be here at 5 because of the 5. Now, this is a decreasing graph. There are no reflections. There's no negative here, there's no negative here. So there are no reflections. So this graph, you know, I'm taking a look, see how the b value is less than 1. That tells me that it's going to be decreasing like this. Alright, so this is our basic sketch. Alright, sure, it's a vertical stretch, but you can't really tell from a basic sketch. Even the minus 4, you know, that means it's to the right 4, but you know, you can't really tell just looking at a basic sketch. So all that really mattered was the plus 5, making sure that this thing is up 5. So I can tell the range now. So the range must be from 5 to infinity. All right, it has a low of 5 and it goes up from there. So that's why the range is going to be from 5 to infinity. Okay, it's all about drawing a basic sketch. Notice I use parentheses, not a square bracket on the 5. This is an asymptote. The graph comes closer and closer to it, but it never touches. So the number 5 itself is not part of the is not one of the y values. It's not part of the function. So you leave it out by using parentheses. Okay, this video is 10 minutes and 30 seconds long. So we have time for number 6. And that'll be a convenient place to stop before we start graphing things. So what is the equation of the horizontal asymptote? Oh, well, that's going to take like 2 seconds. This number on the end tells us the horizontal asymptote. Horizontal lines are always y equals the number. So this horizontal asymptote is y equals -2. All right, not much to that one. All right, I'm going to go ahead and stop the video there because now we get into graphing, which is a whole nother thing. So if you want to know how to graph functions like this, watch the next video.